This morning, I'm going to be sharing the updates of our national scale field trials on the PIPCAP project. And we've been focusing on producing plug plants over the years. And we've indeed made, excuse me, sorry. We're doing something different. Okay. Something is wrong with the phone. So, over the years, we've found that controlled environment technology deployed to produce, to propagate strawberry indoor has been largely successful, and that is at least some of the progresses we've been sharing for the, since yesterday and over the years. So we've been able to produce high quality transplants at unprecedented large quantities, and indeed, with a year-round production capacity. So, but as we know, the nursery industry is perhaps, approximately $250 million worth in the US. So what happens to the $2.8 billion worth of the strawberry fruit industry largely? So we want to see what does the intervention at the nursery level, what does it translate to in terms of the fruit production? And we also went ahead to digging into literatures that artificial chilling has been pinpointed as something that can be an intervention to induce the strawberry plant meristems to improve early fruiting yield of the crop when they are eventually planted on the field. So those informed the hypothesis and the objectives of this study going forward. So we hypothesized that controlled environment plugs can actually produce, similar fruit yields, if not more, as the existing industry standards of strawberry transplants across the strawberry production belts in the United States. And I'm namely talking about the Central California, the Southern California, Florida, and North Carolina. So New York was not involved, was not included in this particular study. Then we also hypothesized that artificial chilling can improve the fruit yield of controlled environment propagated strawberry plug plants, when grown in the field. So,
so your hypothesis, number one, controlled environment plants basically similar to the conventional standard. So why we are doing this?
It was meant to be expected to be higher than it. Yeah, but I was kind of being modest with the way I put this, because we already saw it happen at the nursery stage, that's at the propagation stage. So how will it be when they are planted on the field? So, that prompted the way I presented it. But I agree with you, we should expect it to be more in terms of yield, even though the result we got kind of prove this hypothesis, right? Yeah. So, so we aimed to assess the fruit yield of controlled environment propagated plugs across California, Florida, and North Carolina field. And we also went ahead to determine the yield response of chilled controlled environment propagated strawberry plug plants, in the fields. So you've seen this slide a zillion times, so I'm not going to waste much time on them. So the plants started off as tissue culture plants. They were rooted in the growth chamber under this condition, and they were planted afterwards in a plant factory. And it was a 2-year study that was conducted in 2023/2024, and the second year was 2024/2025. So this particular plant factory I'm showing here was the one that we used to produce the plug plants, essentially the daughter plants, that was used for the first year study. And this shown here was the precision greenhouse that we used to produce the daughter plants that were used for the 2024-2025 study. That was the second year experiment, which was meant to be the validation study. So the plants were rooted in 50-cell trays, and they were transferred into the controlled environment nursery, where they were rooted for another 28 days, after which we did what we call the artificial chilling. We subjected the different cultivars to these chilling hours. You can see on the screen, and that was done at a stage to prepare the plants for shipping at the same time. So at a point when the plants were still in the controlled environment nursery, we would split the population of the plants into two, and we took a half of them into the cooler at 4 degrees C to impose the chilling on them, while the remaining half remained inside the controlled environment nursery, and they were all, shipped the same day to the various locations for field planting. So Florida, Brilliance and Sensation received 350 hours of chilling, and a question that has been asked about why did we select these hours? Well, why were they not uniform? So the intention initially was to make the whole of the cultivars receive 450 hours of chilling. But the particular year we started this trial, we were running out of time to actually meet the planting date in the various locations. So we had to truncate the hours that Brilliance, Sensation, and Monterey received to 350, coupled with some logistical reasons in terms of personnel. I was supposed to resume earlier than the time my visa was approved eventually. So, all those actually culminated to, the shortage of the time that the plants had to spend in the cooler before we shipped them to the various locations. So the Fronteras, which was planted in the field in Southern California, received 450 hours of chilling, while Chandler and Camarosa received 450 as well. And those were planted in North Carolina. So I must also say that during the first year of the trial, the chilled versus no chill plugs versus bare roots. Bare roots was the industry standard that is known in Florida, so planted on the field, as well as known to be used in Central California and Southern California, but in North Carolina we use plug plants for the most part. So in the first year of the trial, we only had the commercial standard in Florida and North Carolina. But in the second trial, this was more uniform. We included the industry standard in both Central California as well as Southern California also, as you will see in the results I'm going to be sharing. So the plants were shipped, to the various locations in San Luis Obispo, in Central California, in Camarillo, Southern California, UFAS in Florida, and in North Carolina, that was in the research station, the CCRS research station. So going to the results of the experiments. So in Central California, the study was conducted and managed by Dr. Gerald Holmes, as well as Samantha. So Monterey was planted in that location. And during the first year of the experiment, we found out that chilling indeed had an effect on the early fruiting of the Monterey plant, and compared to the no chill. And cumulatively also, totaling the yield, across the season, chilling did have conferred 28% increase in the yield of strawberry fruits compared to the no chill treatment. That was during the first year. Then, in the second year of the experiment, we found out that even despite the gap between the no chill and the chill actually were pretty close in terms of yield, and the bare root product, the yield produced by the bare root transplants were actually far down, but still there was no statistical differences across the means compared. So we would say that controlled environment plug plants and bare roots of Monterey were largely similar in terms of yield, and artificial chilling did not have confer an effect in the second year of the experiment.
Can I ask something?
Please go ahead.
Same planting dates or different planting dates?
Uh,
Across the 3 different planting materials. Did you plant anything on the same day?
Yes, they were planted the same for each year. The planting materials were planted the same day.
But within a year?
Yeah.
Okay, so then, so the industry standard in the central, California, when is the typical planting day of the?
So that happens. Some of that, let me, do you want to give the answer to that?
October.
We're only like 2 weeks behind, like.
Yeah, so then did you do October planting?
Yeah.
Okay, so my theory, I may be wrong. So the October planting, the first season, berry plants basically established the vegetative growth.
We didn't do bare root in the first year.
The first year they didn't have bare root. This is the result. So we only compare the chill and the no chill. The second year had bare root.
Yeah, industry standard situation. The bare root comes in October in the soil, right? And then the first, whatever several plants are basically growing for developing the vegetative growth. And then also initiating flower buds. And then, in some cases, and then start picking April time, because the temperature is nice and then, right? So buds, it's already established. So planting could be much later, right, instead of October. So that might reduce some maintenance and labor and that, so that's a sort of one advantage. And I was wondering if there was opportunity to test that.
Didn't you guys do planting very fast?
We did plant to trials with the first year, like.
Yes.
Only with
Only with partners to see if as well.
Yeah. But a lot of we noticed that a lot of the foliage that comes on the post plants, we end up seeing necrosis. I think they're not really like used to the field conditions, they're not. So like they're ahead, but then.
Yeah, but the grounds, you know, you have flower buds and then additional branch around, so that's a. For the trade plants, not blind bud, you know, rooted flowers are not so, I don't know.
Well,
Can I comment on this, because I think we're having this mistake, so. So we don't have arbitrary plant dates, we start counting chill hours on September 1.
Yeah.
So, I guess my bigger concern when we get to the next slide is. 350, nobody would dig Monterey at 350 in a year where they don't have to, they'll wait. So they'll wait to dig it and we'll be very particular about like, we wouldn't even, I mean, Cheryl, are you planting plants at 350? Bare root? I think almost everything that's done for Santa Maria in the north is 400 if we have them. Plus with it and we'll conference supplemental, which doesn't really do anything.
They're not usually telling us, you know, how many hours of chill on them, like you're probably.
But they're not telling you, but we are all doing that for that.
Right.
Like every day right now, I'm checking chill hours at the nursery, so in the nursery. So this is an artificially low chill for a bare root comparison, for a daily triple. So that's a bigger concern.
Thank you.
yeah, and we looked at planting dates and there wasn't a big issue with busy planted in November all the way to the end of November it was. And there wasn't a big impact on the later.
So that means you can wait.
At least in that region.
Yeah,
It's
that's
a bit more pronounced.
And waiting has other issues,
Right.
so if you wait, you run into it being cold when you plant. Instead of warm enough to get the plants up and going. You also run the risk of it raining and not being able to enter the field with your equipment.
I see.
So the longer you delay, the more you're into colder and wetter months.
Yeah,
And then you really run the risk of the plants not establishing.
right.
And the 350, we were shooting for 450, but we had so much issues that in the first year, we just couldn't get to the 350.
Yeah, I know that, well, this is 24, 25, though, 24, we had a good chill in the nurseries.
Yeah.
So I'm surprised this lasted, oh, we're gonna get to your.
Yeah. Yeah.
Yeah,
No, I mean, we in our facility, we had this timing issues.
Oh, with the.
To get to the 450, that's why we did 350, right? That's what it happened, yeah.
And there was no tabletop trial, right? We had,
No.
did you have tabletop?
No, we don't, we did.
Any other observation? Yes.
So they were planted in October in California, so was there infill chill in that location after we were adding the plans yet?
Except for what the natural ambient weather confers, no other chilling that was conferred as well.
Not at all.
Well, you guys must get some infield chill, especially in 24, 25. In Cal Poly.
Yeah, I don't have a number off the top of my head, I don't think that's.
But somebody can go back and pull temperature data.
Any other? All right, so that was the results for the Central California location. Going to Southern California, Camarillo, where Fronteras was actually planted. So Fronteras also received 450 hours of chilling, and in the first year of the study, we also noticed the effect of chilling was a bit pronounced during the early harvest season, and cumulatively also totaling the all season harvest, chilling also had 23% increment, on the fruit yield compared to the no chill treatment in the Fronteras cultivar. So in the second year, however, we noticed, despite the numerical differences, between the plug plants and the bare roots, there were no statistical differences, among the means. So, well, indeed, the chilled plug and the no chill plugs produce quite close, figures in terms of the fruit yield. I wouldn't know what this would translate to in terms of economic implication, talking from the grower's perspective, but I would suspect it may make some difference, especially comparing the plug plants to the bare roots. But, this is what we have statistically.
So sorry, do you have any more data of this trial? Like I'd like to see how soon the plants started the production.
Oh, the
Yeah.
graph is not there.
Yeah, but
Yeah.
can you share your observation or the understanding?
Yeah, so I think during the early period, like we noticed in the first year, during the early harvest period, also in the second year, there was a bit of difference, in the chilling.
No, I'm more interested in comparison with bear. So,
Oh, so bare root, I guess, was maintain the least from inception. Maintain the least, maintained the least.
Yeah, so the start of the production is also later.
Right,
than the plants.
right.
I think that's super important, particularly for Southern
Right.
California.
Yeah, so the chilled plants had like an earlier start than the bare
Yeah.
plants, and then they kind of petered off at the
Yeah,
end,
so,
right?
and then even though the statistical significance was not
Right.
there, I think that biologically, just looking at average, I think it's very important. And then if you did more applications or something, you may be able to show that total is also different.
Right.
But it's because of the Southern California, I wanted to see how early they could. I don't know if that makes
I
sense.
showed the graph.
No, I mean, the market, if you're saying the market, the curves, right,
Yeah.
ladder of the course, you see it significantly, and that you could easily pull the market, average market data from the past 3 years from information.
I showed the graph
And
yesterday.
show that.
I don't know if it's so correct, yes, it's in my presentation, but it came. Early.
Yeah.
Yeah, so
Yeah.
the,
Well, that's right, I remember that, you showed
Yeah,
the
you're-
difference at beginning.
yeah.
Between berry,
We've been
Yeah.
there and
And the blocks.
especially the chilled.
Yeah.
Fronteras, and then the chilled just kind of petered off and the barrel came out a little later.
yeah, I think that's
Yeah.
super.
Yeah, I agree. We saw the same thing in Florida with one. of
Yeah,
them.
Florida too, you wanna
Yeah.
have quickly,
Yeah.
you know, have that fast, you.
Of course, quick harvest, gives the kind of profit early also, to the growers, which is kind of a target that growers also want to meet. Right. So in North Carolina, where we tested Camarosa and Chandler, so in the first year, even though there was no significant differences, across the cultivars, both in the early stage of harvest, the later stage of harvest, and the total across the season. But I mean, we could still see the numerical differences in the values that we have, with the chilled plug producing quite higher, number, of fruit compared to the no chill, talking about the Camarosa. And of course, the commercial plugs were also found to be, quite lower, even in Chandler as well. As we talk about the yields of the plants produced, and they also received 450 hours of chilling in this location. In the second year of the study, yes.
Question, you're showing for the interaction chart. But if we look at like did you look at the main effects of like chilled?
Yeah.
And no chill?
Yeah.
And
So,
for those-
so in terms of the main effects of the study, of course, we consider the cultivar separately, we considered the treatments also separately. Camarosa was indeed higher in production than Chandler, and chilling also had a significant effect. But I'm presenting the interaction here only.
But I think it's important to also mention like the main effects that you had.
Okay.
That if your chilled plugs were higher than the commercial plugs over both cultivars, right?
Good. So in the second year, for Chandler, commercial plugs outperformed the control environment plugs, while for Camarosa, the yields, observed in the, treatment were largely similar. While for the chilled, you say something?
Oh, I was gonna say, big asterisk, for comparison, the 23-24, the 24-25 data. There was a massive difference in quality in the commercial plugs, between those years. In the year before, all of the Camarosa and Chandler, was shipped from, we got our plugs from Fresh Pick both years. The plugs were sent down from Canada, that first year. Calissa has the pictures of plant difference going in, it's significant. The commercial or the controlled environment plugs were much higher quality and they performed quite a bit better through the season. This year, there were the neopest issues in the Canadian nurseries, so Austin Wren propagated the Camarosa himself, and the Camarosa and the Chandler plugs we got from him were roughly equal quality with the commercial environment plugs we got coming in. So big thing to take in mind, you're looking at the data here.
Well, thanks for that. So in the second year, also like I was saying, the chilled Chandler produced quite lesser yield, compared to the commercial plugs, whereas the artificial chilling did not also affect the yields of Camarosa. So, which is a kind of a deviation slightly from what we saw, in the previous year. In Florida, where Brilliance and Sensation were trialed. So in 2023 experiment, we noticed that at the early stage of harvest, that was in November when the harvesting started, the bare roots actually produced quite higher than the chilled plants for Brilliance, whereas for Sensation is, the observation was that the chilled plugs actually produced, reasonably higher than bare roots, but there's an overlap with the no chill plugs, for Sensation. So the observation is kind of cultivar specific, and cumulatively, across the season, we also saw that for both cultivars, the control environment plugs actually had similar yields as the bare roots, whereas artificial chilling did not significantly affect the yield of Brilliance and Sensation. So going forward in the validation trial done in Florida, it was observed again that for Brilliance, chilling actually conferred some effect on the early harvest in November, and indeed the same trend was repeated in December, where the artificial chilling actually produced more yield in Brilliance compared to the no-chill and the bare roots. And the trend actually kind of shifted in January, where we had the bare roots catching up and producing far more than the plug plants, both the chilled and the no-chill. And in February, the yields were quite similar, despite the huge numerical value that was pulled by the bare roots transplants in that field. However, for sensation, the trend was such that no-chill had a delay in the fruit production. In November, it produced nothing, while in December rather, when it did start to producing fruit, it ran at par, with the chilled plugs, while the bare root actually produced significantly more. So the trend was also, quite consistent in January also, where the chilled and the no-chill actually produced similar and lower yields compared to the bare root transplants. And in February, there was no significant differences, across the treatments. So cumulatively, what we saw was that for Brilliance, and indeed the similar trend was observed for sensation. So the no-chill, the bare roots actually produce, quite higher, yield compared to the no-chill, where there's an overlap also, talking about the chilled treatment for both cultivars. And this is statistically different, So summarily, in Florida, we would say that the plant received 350 hours of chilling, and Brilliance and Sensation was trialed. The chilled versus no chill and bare roots were quite similar in yield, and the chill that was in 2023, whereas in the validation experiment in 2024, the chilled actually had similar fruits compared to the bare roots, while no chill plugs had lower yields. In Central California, where Monterey was planted, and the chilling administered was 350 hours. So the chill in the first year of the trial, chilling actually had more effects on the fruit yield compared to the no chill. But when the bare roots was introduced in 2024, the yields were at par across the three types of transplants that were grown. And in Southern California, where Fronteras was planted, and 450 hours of chilling was administered. In the first year, the chilling actually had pronounced effect on the fruit yield compared to the no-chill, while in the validation trial, when the bare roots was also introduced in the field, the yields were similar across the different transplant types. And here in North Carolina, where Camarosa and Chandler were planted, and 450 hours of chilling was imposed. So in the very first year, the chilling versus no chill and commercial produced similar yields, whereas in the second year, I guess when we had a more superior kind of quality of commercial plugs, so the yield produced for Chandler for the commercial plugs were quite higher than the plug plants, regardless of the chilling condition. Whereas for Camarosa, there was no significant differences across the yield produced by the different transplant types.
So I think it would be, like as Sherry said, I think it would be very important to show the differences, especially for Southern California and Florida, a little bit more in detail, like the early fruiting versus the late fruiting, right? Because those are different plants, they have different industries. I think for those two regions, it will be extremely important to not just compare the total year, but to see
the trend across.
I think you also need to put a caveat on all of this. Based on, we don't know what the chilling hours were of the bare root material that went into the trial, at least in Florida, right? So we probably need to ask Shinsuke if he knows what type of chillhouse they receive. And the quality might have also be different between the 2 years, right? So that's something to find out from them. And yeah, I also think that yeah, I think those are the two main points really, I also feel like for Central California and like, so those new graphs, like at the end, that look very significant to me. I'm not sure that I look there, I mean, between the non-chill and the new others, there is like a huge significant difference, right? So that, yeah, I think if you go back to the Ukraine from this season from the Central California region, like this one there, I mean, at the end, that looks very significant to me, right? Like if you see like the chill and the bare root, they're like very similar, and the non-chill is like somewhere down there, right? So, yeah, I think the main takeaway is if we do plans into the chill hours before we go into the field, right? Like if we do like controlled environment plans and what's not performing, I would say that's like a big outcome of this, right? Because no matter which region we went, be it Florida, be it Southern California, or Central California, if we didn't give them any chill hours, we just rooted them same time, same DLI, everything, right? Come to the field, they just didn't perform at all, right?
Yeah, could you review the production condition of the plant plants you used in this trial?
Sure.
How long in the, yeah, so the rooted and how many weeks to grow?
That he knows that a lot better.
Yeah.
than I would, yeah.
Yeah, so they were rooted for 28 days cumulatively,
Say it's
28 days
28
of
days.
rooting, and
Post rooting.
all
Yeah.
All rooting.
of
All
rooting,
rooting.
yeah.
Yeah, and then,
And okay, so within the 28 days of rooting, there was, we set aside 14 days that was meant for chilling to achieve the hours of chilling that we did. So let's say that's the first 2 weeks, all of the plants spent their life inside the nursery. And we split the plants into two afterwards. We took a half into the cooler and the remaining half remained in the nursery for the rest of the 14 days.
so the chilled plants actually grown for only 2 weeks.
Right.
And 2 weeks of
Right.
chilling.
Right.
Non-chill, 4 weeks of growth. Okay. Okay. So it's not trade plants, I got. confused.
No, they're block.
It's like the
Yeah.
28 to 30 day.
Yeah,
Yeah.
Then I also want to, harvest your views on the number of hours that we showed the plants for Florida location especially. It feels that it appears like an overchill for Florida cultivars to receive this
Well, we're
amount.
gonna have to move on though. We can like keep that thought and discuss this later. But we're already running.
Right.
We have to move to the next conversation.
So thank you very much for your attention.
All right.